Windows or Mac OS, and topics include foundational concepts, using the graphical environment and the command line, setting up users and groups, setting settings, managing processes, packages, scripting, and shell programming, and then also an introduction to the C compiler on Linux. So in a Linux system, there are three main components, like really broad strokes. So we're not getting into very much detail here at all, but in broad strokes, when you power on the machine, it'll go into the bootloader eventually. The bootloader is responsible for loading the kernel into memory, which technically Linux is just the kernel. And so it'll load the kernel into memory and run the kernel. And when the kernel runs, it will initialize all of its data structures, all the hardware components it needs to use, and all of that, the scheduler, memory management, virtual memory, all of those, and then start launching user processes. It launches the very first user process called the init process. That actually is the only process that the kernel launches at this time. And that first process that runs is then responsible for launching all the other processes that you use on your computer. So the three main components is the bootloader, the kernel, and then user processes that run. Linux comes in these different flavors called distributions. So a distribution is kind of an installation of Linux. It's a way of setting up Linux and its components. Distributions provide a great service to the Linux community. If we didn't have any Linux distributions, if you wanted to install and use Linux, you would have to get the bootloader, compile that, and put that in your hard drive, put it on the master boot record or whatever on the hard drive. You'd have to compile the kernel, put that on your hard drive. You'd have to compile all of the user space utilities, ls, rm, grep, tar. You'd have to compile and put the graphical environment on there. This would be a lengthy process. It might take you a week to get Linux installed, even if you were fairly savvy. So Linux distributions make this a whole lot easier. They do all of that work for you and usually provide a very simple, straightforward installation process. Sometimes it's even a simple program that gets run and you answer a few questions and it gets done after about 20 minutes or so, depending on how fast your computer is. When they do that, though, they make some choices about components that get included on your system. So they get to choose what graphical environment they want to have as the default graphical environment. They choose what program to use for that first init process for system startup. They choose packages and have a package management system where you can install new packages, new software, and update your existing ones. And so because they make all of these choices, they can make different choices from one to the other. And one of the nice things is you do have so much choice. Sometimes people think that each distribution is a whole separate operating system, but it's not really true. That's not the way Linux people think of it. Linux people kind of think of each different distribution as just another kind of flavor of Linux, where Linux is ice cream and the distribution's chocolate and strawberry and so forth, that kind of thing. When you do run applications in the graphical environment, they have it set up so you can have applications that are meant for one desktop environment run pretty well on others too. So it's not like it's forcing you into certain applications or anything either. Usually they're just set up because you like it to work a certain way. So there's different graphical desktop environments, as we'll see and show you along the way here. So inside of a distribution, that includes the kernel. And so a lot of times in the kernel itself, they will take mainline and use that. And then sometimes, depending on how the distribution operates and works, they'll like stabilize on this version of the mainline kernel. And then they will support that for a length of time. You know, maybe it's long-term support, so they'll support that kernel for a couple of years. And over those 2 years, there might be some bug fixes and critical security fixes that come along the way. And then they'll often include those in the kernel inside the distribution that they provide. Sometimes distributions include other stuff too. Each distribution kind of works a little different. The community, makes different choices in there. But in general, they kind of base what they do off of the mainline kernel and include that, and then also include maybe some other things usually bug fixes and security fixes, but then occasionally they also may include some additional features, but that's not as common. The distribution includes a graphical environment, like we mentioned. So this is an example of like the Ubuntu desktop. This is using GNOME, or a kind of a flavor of GNOME here, where it kind of has these graphical visual elements in it. There's other ones as well, as we'll see later on. But usually they'll include a graphical environment and a way to interact with the computer from a graphical desktop environment here. You can see, and we'll talk about these more later in depth, but you can see there's a file manager, there's a quick launch bar, there's a place for indicators and settings and things on the screen in there. Distributions, like you mentioned before, have a package manager. A package manager is a way for them to let you install new software and update the existing software on your system. There's different formats, different tools used for those. So distributions let you make choices on what's in the distribution. They'll pick defaults for you, whatever they pick for you. You can usually change that later on after you've installed everything except the package manager. The package manager is usually tied very closely to the distribution. It's their package manager that they use, and usually can't swap it out for something else. So sometimes people pick distributions just because they like the package manager that they use in there. And then they can, even if they don't like the desktop environment, they can go in and change that out later. And so the package manager, there's several components that are included with it. They'll have files that represent each package. So like for a Red Hat Fedora type distributions, they'll use RPMs. For Ubuntu Debian-based distributions, they use DEB files. Arch Linux uses something called Pacman. They have different ways of doing it. One of the main differences between a package manager and, say, for example, like the App Store for your phone, is the packages tend to be more granular. So if you want a specific application to be installed on your system using the Linux's packaging system, you can go ahead and install that program, but then it might depend upon other packages. Whereas like the App Store of your phone, I don't know what they do under the hood, but I suspect they don't provide granular packages this way. And they tend to install the same things from this program to that one. You end up with, same libraries between one program and the next, with the libraries duplicated in this directory and that directory. Whereas on Linux, if it needs a certain library to be installed, DLL type of file, on Linux they're called SOs, or shared objects, shared libraries. They'll go into one place on the hard drive, and then all the applications that use it will just link and use that one set of shared libraries. And so they're not duplicated on the system. And so the packages will have these dependencies that are provided in there. And so if you install Super Editor, it might also grab and install Squiblib API, which is something completely made up. And so that's kind of how the packages are. So it's in a central repository online, typically. It's a repository with mirrors. So it's in a central location. But when you do install them, the packages are smaller components or smaller chunks when you put them on your system. Some of the nice things about most Linux distributions is they let you choose when updates happen. So that's where the Windows people go, yay! And in the Linux distribution, they'll provide tools and applications in there. They'll provide some by default to get installed at installation time. But then you can choose to install other things also after it's already set up. So here's a bunch of icons for different kinds of software packages that people might use on a Linux distribution. A lot of these are the same ones that you might have on other OSs as well. And you can use the packaging tools to just go ahead and install Firefox and LibreOffice and whatever you want on the system. Most things these days have a version for Linux as well, although not always, admittedly, but a lot of times they do. And so these days, when you get into Linux, a lot of times it's already applications you're familiar with, which is nice. It's also possible to make your own distribution. I don't expect you folks to be doing something like this right now, although you might be, but just to be aware, you can actually make your own distribution. You might do that because you want more control over what's on your system, but probably the most common reason for making your own distribution is you're working on an embedded system where it's a smaller device and you're putting Linux on it and you're having to make choices about what tools get included there. And there are tools that you can use to create your own distribution for your own embedded devices. Some examples of these tools are BuildRoot, the Yocto project, Open Embedded, OpenWRT as an example here. So we're going to kind of go through different, just two different distributions. I've picked two to showcase. There's thousands of distributions out there. Many distributions use the same desktop environment from one to the other, but there are about 4 or 5 different desktop environments. Didn't really have time to cover all the different types of desktop environments, so I covered just 2. So I picked 2 different distributions with different desktop environments just to kind of showcase what's possible, and you kind of see just at least a couple of examples. So we're going to kind of walk through both Ubuntu with the GNOME desktop and then Manjaro with KDE that's installed on it. So this thing here talks about, this section we're in here talks about finding out what distribution you are running, including which version of the distribution. In the graphical environment, you can bring down, like in Ubuntu GNOME desktop, you can see in the upper right, there's just like this power icon up there, and you can click on that and it brings down this little kind of drop down window here, drop down menu, and you can pick settings. And then when the settings come up, you'll see something like this that comes up. In here, you can go to the About on the left-hand side. In the column, go all the way to the bottom where it says About. And then in there, it'll have the OS name, which includes, in this case, Ubuntu plus its version right there. So it's a way to find out what you're running. So if the screen kind of looks like it did on the previous slide, that's how you can go to find out what is the distribution. By the way, Fedora uses GNOME Desktop and others do too, so it isn't just Ubuntu. But it'll be the same way of getting in and finding what distribution and version you're running. On Manjaro for KDE, it'd be similar. It's the screen's organized differently, so where the menus are and where indicators and settings are is different. But you can go press the in the lower left-hand corner. There's kind of a bluish kind of icon down there, kind of where the Windows logo would be inside the Windows operating system. You can click on that. And when it comes up in the search at the very top, you can type settings. And then you can press enter and run the system settings application. And that will bring up this kind of window for system information. It'll say it's Manjaro Linux. And if you want to find out which version, you can kind of look down below and see which version of Manjaro you're running as well. You can also run this separate Manjaro Hello program that also will display the Manjaro, say that it is Manjaro that you're running, and also display the Manjaro version that you're running in here. You can also find out which distribution you're running from the command line. As we'll talk about later on, you'll see that the command line is considered an equally valid way of interacting with Linux, as is the graphical environment. So other OSs, they tend to push the graphical environment and try to tell people that the graphical environment is the new modern way of doing it, and the command line is this old-fashioned thing, and shame on you for using it kind of thing. Whereas the Linux, they consider either way an equally valid way of interacting with the system. And so you can get into the command line. There's a tool oftentimes available called hostname control. You type that. It'll tell you the name of the host machine. It'll give you which version of the kernel and that sort of information. And then, so back here on the static host name here, it's saying Ubuntu. So it's actually listing the distribution that you're running in there. And then down below, you can see operating system, and it says Ubuntu 2104 in this example here. There's also other ways to find out that same information on the command line. There's multiple ways to do it. So you can use this program or this tool called LSB release. So you can run that with the options DR, and it'll display your distribution. Or you can cat, which is the same as listing out or typing a file. And this file would be in the directory /etc/os release. The information is there too. Some of these methods are common across all distributions, mostly. Some are just on certain distributions and not others. The way you get the distribution information has kind of been changing somewhat, not like super recently, but kind of in the last, couple of years. And so ways you may have used to been getting the version of the distribution and the distribution name might be different now than it was. But these seem to be the common ones that are done these days. So I thought we'd just pause for some discussion. See, there's some questions popping up. So the question for have any thoughts? So I'll go back to this slide here. In really broad strokes, main components in a Linux system is the bootloader, the kernel, and then user processes that run. But with that question, if you answered things like graphical environments and command lines and packages and those kinds of things, that would have been fine too. So if you wanted to answer questions kind of more from this diagram here, that would have been fine as well. All right. Are there any questions? Directories are stored on the disk. It's not really talked about. You just get C:, and your stuff is there. But under the hood, often they're all probably doing something very similar, but Linux exposes more of what's going on and doesn't hide so much. So a lot of times you have these terms that come up and like, what file system are you using? You're like, what? And so here we kind of talk about what that means and what's going on when you access media and disks under Linux. So a file system is a way to organize information for files and directories and other entries on like a hard drive. So here it says on media, but it's on like any sort of disk type of media, hard drives, SSDs, thumb drives, and so forth. And just for discussion purposes, what are some data structures that you might think to use in order to store files and directories on the disk? Like if you were to write some code to store the information on the disk, what sort of data structures might you think to use to store those types of things there? And this is just to get you thinking about file systems in general. So what do you guys think? And use less space. So the idea here is that there are different ways of storing information on the disk. When you have files and directories on there, what's actually stored in there, it might be different from what's called a file system to the next. And they might be optimizing for different things. There's choices there. Yeah, someone's asking, is a B tree the same as a Q tree? I've not heard of Q trees before, but I have heard of B trees. So B trees is kind of typically used for databases, but can be used in file system drivers, file system data structures as well. And it's a way of having like typically a B tree, you have your data all kind of either in a list with links between them or just listed in a file. And then the B tree supplies an index into those. It can do other ways too. There's different flavors of B trees, but in general, that's how they're set up. So on Linux, there are different file system structures, different file system formats. The way people talk about it is there are different file systems, different ways of storing the information about files and directories and other things on the disk. On Linux, they have these different names. So there's ext2, ext3, ext4. These are kind of extensions of each other. And the ext stands for, I think it stands for Extended File System. And so basically they've modified the ext2 file system as time has gone on. So the current iteration of it these days is ext4, which allows for bigger disks and bigger file sizes on there. But other options you might pick might be XFS, or one here is BTRFS, as people pronounce it as ButterFS. And they store information differently, and the characteristics might be different. They might be faster, and they may also maybe use more disk space for files and things on there, just because of the way things are organized. Windows primarily uses NTFS. They may use other things for removable media, drives that can be added and removed and be kind of external drives. But internally, they tend to use NTFS. That's what's there. They don't talk about it so much, and the average typical user isn't aware that it's called NTFS or that there's even some sort of format there. They don't really think about it as much. macOS primarily uses APFS, but they might use others as well. And so each format for the file system is optimized for certain use cases. And Linux is very explicit about the file systems. So if you were to add a brand new disk to your system, let me jump forward just a little bit here. If you were to add a whole new drive, you'd be very clear what file system you're using in Linux. You would go to the drive and create one or more partitions on the drive because it's partitionable media. And then you would create a brand new empty file system on that partition, or partitions if you're doing more than one. You would be picking, I want XFS to be there, or I want it to be ext4 or ButterFS or anything in there. And then you would attach the file system to a directory called mounting, which I'll talk about next. It's on the slide I just skipped over, which I'm going to go back to. But in Linux, these steps are very clear. You don't just put the drive in and click a menu that says format and ta-da, it's done. In Linux, the things that would normally be done when you format the drive are separate steps in here. So you have to go through and do the steps one at a time, and that lets you pick. That lets you give you some choice about what happens. So under Linux, they have this different concept for providing the files and directories to you from the media, the disk drives that are there. To compare, to Windows, you have a main hard drive internally in a computer. In Windows, it would be stored as NTFS probably, and in there would have program files, x86, users, Windows, and other directories in there. And that content on the disk would be attached to a drive letter, C:, for instance. So you go to your C:, and you would see the files in there, and it just shows up as C:, and you see all the contents under there. If you had an external drive that you have in the system, and that one may have on it videos, audio, and books, it might be exFAT formatted file system on there. In Windows, if you added that to your system, it would just show up on the next drive letter as D:. And then if you had a thumb drive, maybe on there's homework, reports, and stick game, that might be FAT32 as the format for the file system. When you plug that in, it would just pick the next drive letter, and it would be E:. So each one of these is its separate drive letter. The drive letters might not be consistent. So if you remove the thumb drive and the external drive and then plug them in the other order, the thumb drive might be D:, and the external drive might be E:. On Linux, it's this single hierarchy of files and directories. Everything starts with /. The main drive for the OS on the system will have different contents for the OS. So I have bin, sbin, etc, home, media, and so forth in here. It's not the full listing here, but that'll be on this disk. And it would be attached to a directory called /. Note that in Windows, the separator between directories is a \. On Linux, it's a /. So the topmost file system, called the root file system, will be attached to /. Attaching it to / is a process called mounting. That's what it's called. So you'd say, I need to mount my root file system. And because you're saying root file system, it's implied it's going to go on /. and when it's attached there, when this drive, this file system is associated with this directory, all its contents show up under this directory. And then instead of having drive letters, if you had that same external drive attached to your Linux machine, it would have videos, audio, and books, for instance. It would get mounted or attached to, associated with a path that already exists on the system. So it might go into /media/ext_hd, for instance. Many distributions kind of pick a default path to attach it to, but oftentimes you have control over this. So if you don't like it being under media/ext_hd, you can pick some other directory to attach it to. When this file system gets attached to or mounted on a directory, the contents of that directory, if there are any, become hidden. They are not deleted. You just don't see them there. You see the file system that's mounted on the directory. So typically, you mount file systems to empty directories. And then lastly, if you have your thumb drive, that would be mounted too. And maybe there might be mounted on /media/thumb. And so homework report, stick game shows up there. So there's no drive letters, and it's a single hierarchy of files and directories. As you traverse down a path, you might be interacting with 1, 2, 3, 4, or even more different file system types as different media is mounted under different directories in there. If you want to see where your drives are attached, like you want to see where they're mounted, you can type mount at the command line. It'll give you a big long list of where all these different file systems are connected. And then you can search for the paths, and you can search for information about the different drives and kind of see where to see the contents of the drive, like which directory do you go to see the contents on the drive. So I've already talked about this. This is what you have to do if you're going to add a new drive to your system. So you have to be explicit about it. You need to create a new partition table, put an empty file system on it, and then attach that file system to a directory. You mount it somewhere. And then someone's asking, is ext applicable for internal drive and external drive if the file system is implemented as exFAT? Yeah, so if the drive is used on Linux only, then it might be common to put something like ext4 on it because you're not expecting to share the drive and attach it to another OS. So Windows and like Mac OS, I don't know if they would necessarily know about ext4 or know how to read the file system on those. And so you might put something like exFAT on it as a file system type so that other OSs can read the data too. So it's more about what other OSs can read and access. Otherwise, if it's just internal Linux, you can kind of pick whatever you want. Some file systems are considered native file systems to Linux. They support storing all the file attributes that Linux likes to store, including extended attributes and other things on there. If you use something like exFAT, you wouldn't want to use that for your internal Linux drive because you can't store all of the file information, all of the metadata there that you want to store with your files. So your permissions for read, write, execute, and those kinds of things might not really be present. It'll be hard to manage. That's why you wouldn't use exFAT internal in your Linux drive there. But you might have it on an external drive because you might want to share the drive with somebody else who's not using Linux. That's a great question, by the way. Is NTFS supported on Linux? It actually is. For the longest time, NTFS was read-only, but you can now actually write to it. I think for the most common cases, it works pretty well. I've heard of some people encountering some corner cases where it doesn't quite do the right thing. I've not encountered those personally, but it seems to be working. The reading part of it seems to work pretty well. And I think it's only in writing are there occasional corner cases that crop up. But again, like I said, I've not encountered those corner cases, and it's worked fine for me. So here it kind of talks about the topmost directory. So the main hard drive in your system will have these directories. The operating system, Linux, expects certain directories to be laid out a certain way. The kernel itself doesn't care, but this is the convention where things go on a Linux system for user space things. So the file system mounted on slash is expected to have these directories in them. And so here's going to talk about what those directories are and what they mean, what they're for. So the first one is /bin. So these are for programs. It says commands here. Commands and programs are the same, and it's for used in early startup. SBin is the same, but it's for the special user called root, which is the system administrator. The etc directory contains configuration files. Most configuration files in Linux are all just plain text files. You can go in and edit them and change them however you want. It makes it easy to configure. You don't have to run a special program to change configuration. You just open them up in your favorite editor, make changes, and save it. The root directory, if it exists, is the home directory for the user called root. It's not always present. It depends. /lib is for shared libraries. I mentioned earlier that shared libraries on Linux are not called DLLs. They are called .sos. They actually are not called by their extension so much. People don't talk about the extension, but that's what the extension is. People just call them as shared libraries. That's what they say. That's how they're referred to. The lib modules directory contains kernel modules, which is kernel code that's loaded late. /dev contains special entries that represent hardware devices. In Linux, they have a philosophy that they can treat everything like it's a file. And so they have these special entries under /dev. It represents a hardware device, but you open it and access it just like it's a file. It ends up interacting with the correct driver for that device and controlling the device under the hood. /tmp is short for temporary. It's for temporary files. These files typically are in a RAM disk, so they're in memory. They don't persist across a reboot. They're temporary. /boot is used to boot. It's used by the bootloader. The kernel's binary program exists there if the boot directory exists on your system, which it typically does on an x86 system. It includes a few other files as well, but that's files used for starting up the kernel. /mnt is just an empty directory for the sysadmin to mount a file system. So that way you don't have to worry about overwriting stuff, and it just already exists there. Question in chat is, what does kernel modules contain? It contains code. So it's code. A lot of times they're drivers, but not always. So drivers can be compiled and linked into the kernel, just in the kernel binary, or they can be set up to be inside separate loadable modules, where the modules are loaded when the device is present and not needed to be loaded if the device is not present. But modules do other things too. It's not just drivers, but that is an example. Next, the /home directory are directories for users. So when users have an account on the system, they typically end up having a separate home directory. So it's /home/ and then the user name. That's where when you're logged in, you can store all your local files unique to you right there. And you can include whatever you want in there, your own documents. Like if you have an email program that downloads email, it'd probably go in your home directory somewhere. It's kind of like the users directory under Windows. USR is short for user, for users to run. These are commands or programs for people logged into the computer to run. Underneath user, they'll have bin directory and maybe SBin directories on there. And they're not really needed for early startup, but they're useful for you're just on the system and using it. And the reason they split these up oftentimes is when they booted the machine, oftentimes the hard drive mounted under bin and SBin here would be a different hard drive than for the other things. So they could swap out the OS and upgrade it and not affect the user directory or the home directory. Those can be kept separate. And it makes it a little bit easier to upgrade your system. That's kind of in older days, like older Unix days. I don't know if that's done very much on Linux itself, but it's kind of its history where it comes from, and it kind of still hangs around today. /var is for variable files. That's what the var is short for, variable files. So like log files, sometimes files for services like your web server, and things may end up in /var. It's like sometimes the directories, like everybody can't agree that what's in var is always the same. So sometimes you have some variation where like your web server files might be somewhere else. But this is intended for variable files, like log files is a good example. And then finally, we'll talk here about proc and /sys here. Those are special file systems. They're called pseudo file systems. They don't exist on the disk anywhere. The entries in there are supplied by the kernel code. It looks like files and directories, but you can't write there. The directories are not writable, and it just is there to provide information about your system, typically information that's in the kernel. So in /proc, you can have entries like there for mem info, CPU info, and then you can go in and find out information about memory, like how much memory is free, how much is in use, or get information about your CPUs. It's similar for /sys. You can find out information about your system and devices under /sys. So what are the steps you would need to take to add a second new disk to your Linux system? That's for you folks to answer.